Hi, my name is Melissa Rivas and I am a student at UNE. I am currently enrolled in the organic chemistry course, and this video will be for Chem 1020, the lecture portion. This assignment is for week 15 and I am in group 10. So in this video I will be going over combined spectral problems. And we'll start off with the IR spectrum. This is our molecular formula that is given, and we'll be going through a few pages. So in the top left you see our formula, and on our right side we see our degree of unsaturation along with our formula. So we'll be going over that, which is 2 times the number of carbon atoms plus 2, and the number of carbon atoms we have is 10. Then we add the number of nitrogen atoms, which in our case would be 0, and then we subtract the number of hydrogen atoms, and that would be 12. So we add all of that up and then divide that by 2, which gives us 5 degrees of unsaturation. So we will go back to our first page. We'll start in our IR spectrum chart, or graph. So our first peak, which is at 3050, we have CH sp2 right here. The second one right here that looks broad, it is between 2850 and 2950, about 2900. That will be our methyl group, which is sp3, C single bonded to an H. And then this very strong and large peak right here is at 1710, 1715. That is our ketone. We have a carbon double bonded to an oxygen. And then this peak right here is at 1550. We have a carbon double bonded to another carbon. And this last peak right here is our sp3 carbon single bonded to another oxygen. So that is our entire IR spectrum. This contains about 4 or 6 carbons from our formula. Then we will move on to our NMR spectrum down here. So we start off at 29 ppm. We have our methyl group, and then at 45 ppm we have CH2, and right here is a little tight to see, but we have at 125 our aromatic C, which is carbon. At 128 ppm we have another aromatic carbon, and then at 140 ppm we also have an aromatic carbon. Lastly, at 207 ppm we have carbon double bonded to our oxygen, which will be in our, well, all of this will be in our proposed structure, but the last one will show our second carbon. And then lastly, we will go over our H spectrum, which is also called the proton spectrum. So I'll zoom in a bit here, at 2.10 ppm, we have a singlet, and that is 3 hydrogens that are bonded with sp3 carbons. At 2.75 to 2.80 ppm, we have a sextet. Here we have 4 hydrogens bonded to carbon. And lastly, at 7.35 to 7.45 ppm, we have a multiplet, and that is our 5 hydrogens bonded to aromatic carbons. So here in this chart, I have everything we just went over. And like I said, our 207 ppm is located right here. We have our carbon double bonded to the oxygen, and this is my proposed structure after viewing all the spectrums, and I have numbered every carbon on it as well. And that is it. Thank you so much for watching.